All right, here we go. Final lesson of chapter 7. So this is 7.5 part 2. We are still solving equations. The difference now is it's not just two fractions. So we're not able to cross multiply like we were solving. So we're going to solve these guys by taking a common denominator and distributing it to the entire problem. So if we were to say what's a value that 7 and x both go into, well, 7x would be something that they both go into. The idea is we want to cancel out these denominators so that we don't have fractions anymore. So I need the 7 to cancel out with my 7, and I need the x to cancel out with my x. So if it helps, you can think of this as 7x over 1. And all we're doing with it is we are going to distribute this. Sorry, let me get my hand out of the way. Is distribute this to all three terms in the problem. So I'm just going to start out with my first term. So if I were to multiply this times this, one thing I want you to notice is my 7s would cancel, which is the whole point of using this, is because I want to cancel out that 7 right there. So I have a 7 on top, I have another 7 on bottom, so they should cancel. And what would I be left with? If those guys cancel, all I have left is the 4 and the x. So that's what we're going to bring down. And then they'll go over to your middle term. So if I were to multiply these two terms together, again, you'll see that the two x's now cancel, which again is the whole point of doing this, is to cancel out this x right here. And what are we left with? I would be left with 1 times 7. So we're going to bring down the minus 7. And if I go to my third term, as I multiply those together, he's not a fraction. Nothing is going to cancel. So we just multiply these guys together and get 42x. There we go. So real basic equation to solve from here. We would subtract 4x from both sides. Divide by 38. And we have our solution. So that would be our answer. And again, just take a peek, make sure you have a valid answer. Remember, you would not be allowed to have a solution of 0, because that would create that 0 denominator right there. So just be on the lookout for those. Let's jump over to this one. I'm going to get rid of the 6 so that I can make my work a little more clear, hopefully, for you. So again, the idea is we want to get rid of all those guys. That's the goal. So I need something that would cancel out x plus 1, which of course would have to be x plus 1. So we're going to use that one to cancel out him. I'm also going to need an x plus 2 in order to cancel out those guys. So we're also going to bring up the x plus 2. And so that's our common denominator. We're going to distribute that to all three terms, and it should give us a new equation that doesn't have any fractions in it anymore. That's the goal. So as we distribute that to our first term, again, really what you're looking for on this is what would cancel. And if it helps, I'll do this so you can see what's on top and what's on bottom. So because I have an x plus 1 on top and I have an x plus 1 on bottom, those would cancel. What are we left with? I'm left with the x plus 2 and the 3. So that's what I'm going to bring down. And go over to your middle terms. So now we're going to distribute here. And again, what would cancel? I got an x plus 2 that would cancel on both. And if those guys cancel, what would we be left with? Just the 4 and the x plus 1. And go over to the final term here. So if we multiply this, again you can see the x plus 2's would cancel. And all I would have left are the 15 and the x plus 1. So we're going to bring those down. And then from there, it's just basic solving. So you got to distribute and then get x by itself. And I already know you guys can do that. So, and I'll just tell you the answer. So if you give that a shot, here's how you'll know if you did it right. You would get negative 5 over 8 as your solution. So you can try solving that one, but it's just a basic linear equation that you would be solving. All right, I got 2 last things to show you. Take a look at number 7. So one thing that's super important on these is if you have something that could be broken down or factored, you want to put it in factored form before you try to do all this stuff. So we want to see it so that it looks like this and not like this, right? Because we need to see what the individual parts are. And before we finish off this one, my son wants to say hi to you guys real quick, so I'm going to show you him. He's standing over here.
It's upside down.
Oh, yeah, you're upside down, buddy. That's okay. We're just going to have to go with it. Oh, hold on. I'll hold it still. Now you move.
Yeah.
Can you duck into it so he can see you? All right. Back to math. So here we go. So if we are solving this guy again, the goal is to get rid of all these values on bottom so that we get a new equation with no more fractions. So our goal is to get rid of those 3 things on bottom. So we're going to need something to cancel out the x plus 4s, which would mean we're going to need x plus 4. I'm also going to need something to cancel out those x's. So we're also going to have to include an x. So that's what we're going to distribute to everything in order to get rid of those denominators down there. So as I start distributing here, so if I distribute those guys to my first term, again, look at what would cancel. So the x plus 4s would cancel. And all I would be left with is the 12 and the x. Now I'm just bringing down this minus sign. As we go to your middle term, you can see that the x's would cancel. And all I'm left with is the 7 and the x plus 4. Bring down that equal sign, and at the end, everything cancels, which is super nice. And all I would be left with then is this 22 on top. And again, now you have a nice, easy equation to solve. I'm going to take it one more step because I just want to remind you guys to be careful when you distribute. The negative sign goes with it. So you should have a negative 7x minus 28 equals 22. And then solving from there would be nice and simple. So you can get x by itself. So one last thing I got to show you. So hang with me for one more problem here. This is the fun one. So take a look at number 11 with me. All right. So like I mentioned, for a case like this, you do need to put this into factored form. So before you try to start figuring out denominators and canceling stuff out, you always want to make sure everything is in factored form first. So x minus 5 and x plus 2. So we're not going to look at it that way, we're going to look at it this way. So again, I'm going to need something to cancel this guy out. I'm also going to need something to cancel this guy out. So we're going to need the x minus 5 as well as the x plus 2. And I'm going to show you this one as it's already been pre-written for you guys. So again, we're going to distribute this to everything. And the whole key on this is to see what cancels. Because remember, if we do this right, my denominators should all cancel. And I get a new equation with no more fractions. So as I distribute my first term, the x minus 5s would cancel. I would be left with just the x and the x plus 2, which is what you're seeing right there. We're going to bring down that plus sign. As I distribute it to my middle term, the x plus 2s would cancel. And I'm left with just a 2 and an x minus 5. That's what you're seeing right there. And the last term, everything cancels. All you got left is the 11, which is that guy right there. So the only reason I had this one pre-written out to show you guys is if you continue on this path here, you'll notice you do get a quadratic out of this. And so just remember, once you see that x squared, get everything onto one side to make it equal 0, and then we're going to solve by factoring. And those would be our two solutions right there. So that's it, done with chapter 7.